Okay. So we were discussing about design for X, right? So this is
Yes,
over.
sir.
So the problem demanding DFX is over, right? So what are the problems? Okay, that the industries or companies will be facing, right? Why you want DFX? So due to these problems, okay, we will go for DFX. That is design for excellence. So design for manufacturing and assembly is over. So now we are speaking about what is means reliability, right? So right, students.
So we had finished this one also, sir. Design for reliability.
Okay, okay. Okay. Next we'll okay, once again I will repeat, then I will go for the next slide. Okay. So here, okay, we should analyze the load strength relationship. As you know, what is reliability is quality over a period of time. So if you are manufacturing 10,000 components, so 10,000 components also the quality should be good throughout the time of manufacturing around 10,000 products. Okay, if the company gives the same quality, okay, with respect to the dimensions, okay, which we are manufacturing, the component with respect to the material quality, everything, okay, it should be an 100% okay. Okay, so then it is called as reliability. Okay, the ability of a item to perform a required function. I told you what is the required function. That is depending upon the customer needs. What are the customer is asking. So if I am the owner or the entrepreneur, if I give that requirement, okay, what they are asking, okay, in the form of the product, they'll be satisfied under stated condition, whatever they ask, okay, for a stated period of time. So if they ask around 10,000 products, okay, they will ask some function with respect to some product. So if I succeed that product to manufacture regarding to the quality, regarding to the dimensions, regarding to the required output, okay, what they are asking, so that is called as reliability. So how we can check the reliability? By doing the load strength analysis, right? So right, students.
Yes, sir.
So if you want to know whether the design can sustain that much load or not, so for that we should go for load strength analysis. Okay, if we do that load strength analysis, then only we can find whether the material can stand that much load or not. Okay, for that purpose we should do the analysis of load strength relationship. Either you can do the fatigue analysis or creep analysis or whatever it may be, depending upon the application. Okay, where you are applying the product. Okay, depending upon that we should do the analysis. Okay, then design out inherent weaknesses. So we should eliminate those weaknesses, right? For that we should go for analyze potential failure mechanisms and remove or accommodate. So this indicates, okay, we should do the stress analysis, and if the design is not safe, then we should redesign, right? Then we should go for redesign the structure. Sir, okay. So redesign the structure, that is one thing. Or okay, or we can go for a new product, or we can eliminate that product. Okay, after redesign also, if that material or if that product is not sustaining that much load, then we should go for a new product development. Okay, then analyze potential failure modes. So I told you, okay, on which mode, on which frequency does the failure has been occurring. Okay, that vibration is very important. Okay, so because if you go for each applications, everywhere there, so there'll be a vibrations. So then we should analyze if, which mode the material is getting failure. Then past data, so we should use the past data to analyze all these things, right? I told you about these things in the previous class. Past data and supplier history. Okay, if you look all these things, then only we can eliminate the weaknesses of the product, and we can update our product with respect to new technology, okay, or new design or whatever it may be. Okay, if you are very creative, then you will give a new design for the customers. So I'm telling you, think creatively. Okay, you should think creatively and innovatively, so that you can give better product for the customers. Okay, so that if you do all these things, then we can remove the weaknesses, okay, in the product. Then we can improve our reliability. That means we can reach to the customer needs, whatever the customer is asking. Okay, we can reach to the customer needs. Then plan Then plan correct testing. So testing is important, right? So once you do testing, then only we can get the results, right? So according to the improvement, okay, again you test, again if you need to improve, again do some redesign work, okay, according to the needs of the customers. Then why do products fails? So can anyone tell me, so what are the things I've written here? Why do product fails? Students, can you hear me?
Yes, sir, you're audible, sir.
Okay. The first one I have written, design inherently incapable. What is the meaning of that?
So not able to perform its task which it is meant to do.
Yes, one thing. Then I mentioned design.
Yes, as for the design itself, sir.
Yes, that's the design. Okay, that according to the customer needs, okay, it is not reached. Okay, so if you apply less load itself, the material is going to get failure. So that is due to that. Okay, the customers are not satisfied. Okay, due to the design. As a product design engineer, okay, he has not designed well. Okay, so that the material cannot withstand the load which is given by the customers. Next, item overstressed. What is the item overstressed?
So SCFs, I think too much of stress concentrated at a particular region can lead to damage of a product at a faster rate.
Yes, good. So that is called as item overstress. Okay, due to the load which we are applying, okay, within less load only it can overstress because of the because they have mentioned the corner. Okay, corner, if they mention more corners in the material, okay, due to that, so there will be stress concentration. There will be stress concentration will be high, so that the material can get failed. Then what is this variation?
So not like assume you're making a product, but it's only for one type of customer. You need to have certain variation, like for the like in phones itself. Sir. You have one in the range of 21,000 budget, then again same thing for 25,000 like that, sir.
Okay, so that is one, and variation in the sense of the dimensions. So there should no variation should be there. See, one product it may be 25 mm. So another product, if you manufacture 25.5 mm, then it is best, right? So there should be no variation in the while manufacturing the dimensions. Okay, they should not vary. So if they vary the dimensions, then what happens? So there will be change. So there will be change in the dimensions that while assembling. So we cannot assemble the products, right? So if there are like 100 products are there, so in 100 products, 100 parts, okay, if you go for assemble, all 100 parts should be having same dimensions. If one dimension changes, then what happens? Then we cannot assemble the product. So that's called variation in the dimensions. Then wear out. What is this wear out?
So like after using for a certain interval, the product get damaged easily. Like lubrication is not much, less lubrication, so too much of friction between the parts, moving parts, that leads to the damage of product at the earlier stages.
Okay, good. So that's wear out. Okay, due to the lubrication. So there's no example if you go for the engine itself. Okay, so every I think if every I think 3,000 to 4,000 kilometers, we should change the engine oil. Okay, if you do not change the engine oil, and if you use this bike, what happens? So there will be more wear will be okay. So there will be more wear will be present. Okay, on the piston as well as cylinder. So there will be more wear. So this indicates we should use the engine with respect to the lubrication. That is your engine oil. So always we should replace the engine oil every 2,000 to 3,000 kilometers. Okay. So this is what is wear out. So if there's more wear, then what happens? The material the material can stand to the mentioned life. Okay, whatever the company says. Then specifications, that is design or coding error. So if the design error is there, automatically what happens? So it can sustain the load, and losses noise. What is this noise?
So if the product is producing too much noise, like you want a product that is like performing the active function but not disturbing anyone else. Like assume mixie, sir. Right now we have noiseless mixie.
Hmm.
So when
Yes.
that comes into the market, the early existing product market demand automatically drops.
Yes, noise indicates your vibrations. So if there's vibrations, that indicates noise. So if more vibrations is there, then automatically so there'll be more noise. So due to the natural frequency, whenever the natural frequency is equal to the force frequency, the resonance occurs. So if more vibrations is there, what happens? The resonance can occur easily. So we should control the noise. Okay, noise in the product. Then design for reliability. Then so due to this, I think 5 to 6 reasons, because the products may fail. Okay, due to the wear out, due to the variation in design, due to the design is not correct. Okay, due to the vibrations on the in the design or in the product, or it may be item will be overstressed. Okay, due to the load which we are applying to the product. Okay, due to these 5 to 6 reasons, okay, the product may fail. Okay, so next, design for that is reliability. Here the aim to maximize reliability during service life. So how to increase the reliability? Okay, you are studying here how to increase the reliability. So how we can increase? So you can see there are 4 points you should remember. So measurement and control of manufacturing quality and screen, right? Always you should measure see, measurement is nothing but the dimensions, right? Right,
Yes,
students?
sir.
So every time I told you, if you go for industry, every 100 pieces, every 100 pieces, okay, you should check the dimensions, whether the dimensions is changing or not. Okay, and we should control that one. So if dimensions are changing with respect to every 100 products, what we should do? We should control that one, right? See, once the dimension changes, then what happens? Okay, now the parts will get okay, but when you go for assembling the parts, so at that particular point, okay, so you will get a lot of problems. So with respect to dimension only, we should manufacture the products, so that every 100 pieces, if you check and if you intimate, okay, the quality of the quality of the product as well as the dimensions are okay. Okay, then only in the while assembling the parts, okay, then it will easily assemble. So that is one thing. So we should screen is nothing but for every 100 pieces we should check the quality of the product, and we should check the dimensions, okay, whether the dimensions is changing or not. Okay, regarding to the 2D, you will be having the 2D drawing, you should check and you should intimate whether that dimensions are changing or not. Okay, this is what is the first step. First step is to maximize the reliability. Okay, according to the service life. So you should check the dimensions of for every 100 pieces, as well as we should check the quality of the product. Okay, that is screening. Second, optimize design and build process to improve intrinsic reliability. What is the meaning of this, students?
So
What is
it is
this?
like, I think so, improving the design, sir,
Yes.
to improve the
So
quality of the product, sir.
yes, to improve the quality of the product. Okay, always we should try to improve the design. So today we don't know. Okay, we have some design. After 3 months, okay, we should optimize the design, whether we can change the design or not, whether the design is okay for the customers. Okay, if the customer are asking we want a different design, then how we can optimize your old design. So always we should check, okay, and we should try to optimize the designs, okay, according to the customer needs. Okay, and we should try to improve the if you improve their design, okay, if the design sustain more stress, then that indicates the customer will be happy. Okay, the customer feels okay according to whatever they ask the function. Okay, if they give the product according to that, then they'll be satisfied. Then assure no systematic faults present in product. So systematic means, okay, we should not faults in the sense of so there'll be no, what you can say, the some voids. Example, okay, if you take like 100 products, if you're manufacturing casting, so if you do casting there, so there'll be number of voids to be present, right? It may be different types of crystal imperfections may present, like it may be the voids which may be present, or line defects, or you can go for the vacancy defects, right? So these are the defects. If you take 100 pieces, okay, 100 pieces 100 pieces should be also should do not have the faults. So right, students? So we should manufacture the product like that. So there should be no crystal imperfection should be present inside the material. So for that, what method I should use, which technology I should use? Okay, you should think more, and you should eliminate those crystal imperfections which is present in the material, right?
Yes, sir.
So assure no systematic faults. So you should not see in one material if you get some crystal imperfections. Okay, immediately you should change the methodology, or you should change the technology, so that your crystal imperfection should be eliminated. Okay, if more vacancy type of voids are there inside the material, then what happens? Okay, then our strength will be weakening in the brittle material. So I'm telling an example. So always you should be careful while manufacturing the products. Okay, in castings. Then provide sufficient margin to meet life requirements. What is this? What is the
So is
fourth
it
point?
again the tolerance and all those regions, sir?
Yes. So while assembling the product, so we should give some tolerance to the material, right? Like 25.1, 25.2, whatever it may be. Okay, they'll give the margin for you. So why while assembling, okay, it should not it means it should not the dimensions from one part to another part. Okay, it should be same, or it should be nearest to, like, if one part is 25.1, other part should be, if you're shifting the shaft inside the hollow some material, then if this shaft is 25.1, that the dimension is 25.1, the another the hollow structure should be around 25. Okay, at 25 point, the diameter should be near to 25.1 to 25.2, then only the shaft can go inside that hollow structure. So this is an example. Okay, always we should meet that margin. We should give the margin for the for the material. Okay, while assembling. Then we'll go for design for reliability. So design for useful life. Okay, then here, to eliminate those weaknesses, so you have different tools. So right now I think the students know FEM, right? So right,
Yes,
students.
sir.
So you know FEM. So there are another different processes. Okay, like FMECA. Okay, failure mode analysis. Then fault tree analysis. That is FTA. Physics of failure. Okay, then development testing, data analysis. There are different types of testings are there. Okay, in the industry. If you go for industry, okay, you can work in FEA. You can work in physics of failure. If you can work in fault tree analysis. Okay, so development testing, data analysis. So everything is a tool, okay, which they are using to eliminate the weaknesses in the material. Okay, to what you can say, to reach the reliability, to reach the customer needs, whatever they are asking. Okay, we should use these tools to improve the material. What you can say, the material, like it may be designed, or it may be the material, which type of material we should use to sustain, to reach the reliability. Okay, everything. Okay, we can use these different types of tools. Okay, next we can go for design for maintainability. So what is the design for maintainability? What is the meaning of DFM?
So I think it is to reduce that amount of time you need to give your product for maintenance, sir.
Okay, good. So design of components and constructional systems as function of machining process. So this is design for machinability. So here you can see, so there are around 5 points you can see. That's to minimize the downtime, or the downtime for maintenance, right? User and technician maintenance time. So to reduce the time to manufacture the products. Okay, to minimize, one is the downtime for maintenance. Okay, next, user and technician maintenance time. Then personal injury, then resulting from maintenance task. Cost reducing from then maintainability features, and requirements for replacement parts, backups, units, and personnel. So your design for maintainability is used for all these things. One is to reduce the time. Okay, a time for maintenance. See, if something happens, so if you supply your product for the X company, okay, so they should do maintenance, right?
Yes, sir.
So for maintenance, everything will come under picture. Cost, then injury, personal injury may happen. Okay, while using the machines. Then user and technician maintenance time. So to the technician also, you should maintain the time. See, example, if X company has taken CNC machine, okay, if they want to work on CNC machine, so simply they cannot keep the workpiece and they cannot on. Okay, they should write the CNC programming. So that's what is maintenance. So immediately, see, if you take the CNC machine, immediately we cannot work on CNC machine. So we should write the programming according to the 2D drawing. Okay, whatever they mentioned in tool drawing, we should convert in the form of the programs. I think you studied in the CNC programming, right, in the previous semester. I think sixth semester or fifth semester, right? So right, Sachin. So we should write the CNC programming, then only we can work on CNC machines. So immediately we cannot go and work on CNC machine. Next we'll go for next design for life cycle cost. What is the meaning of life cycle cost, students?
So I think you need to consider for each process like how much it will take, how much it will cost you for each process to develop a complete product.
Okay, good. Design for
And
life.
along with it, I think even the maintenance and changing the parts and all those things, sir.
Okay, good. So DCC is called as design for life cycle cost. So it involves throughout the manufacturing of the products. That is called life cycle cost. So how much the company is investing for manufacturing the products. Okay, that is called real cost of the design. So how much you are investing for developing a design. Which and next you can see includes the associated cost of defects. Okay, then buybacks, distribution support, warranty, and the implementation cost of all employed DFX methods. So how much you are investing for all these things. So like if you go for the reliability, okay, if you're going for FEM, like FEA, if you're doing FEA analysis in the in the industry, so what is the cost I am investing? If I go for the design thinking team, how much I mean investing for design thinking team to do the to get the empathy space or to define the prompt statement. Okay, how much the CEO is investing or how much the entrepreneur is investing. So like that, okay, if you go for each one department, so how much you will be investing the cost. Okay, so for defects, maybe defects, or it may be distribution support. Distribution support is nothing but distribution of the products. So how much he is investing for that? For warranty, how much he is investing? Okay, and implementing cost of all employed DFX method. So if you see the DFX method, so I think 7 to 8 methods are there, right? You can see here. So these are the methods, right? So these are the types of design. So for each one, how much the company has invested, how much they invested the amount or money, or it may be the cost. Okay. So in the third point, you can see activity based cost is a method for estimating life cycle design costs, right? It's called as ABC, activity based cost. It's a method for estimating life cycle design cost. So if you go for a new product development, new product, so then you should invest more, right, Sachin?
Yes, sir.
Because see, already existing product, only if you want to add some technology to that, and if you supply, okay, then it will cost less. But when you go for a new product development, then you want design thinking team, so that they should go to the customers. Okay, they should ask the customer needs. Okay, regarding to that only we should manufacture, or we should go for a new product development. So it required more cost, okay, in the new product development phase. But when you update any new technology to the existing product, then the requirement cost is less in the designing part. Okay, the cost will be less. So this is called activity based cost. It's a method for estimating life cycle design cost. If you go for new product development, the ABC is more. Your activity based cost will be more regarding to the updation of the technology in the existing product. So this ABC will be always depends upon the whether you are going for a new product development or you are going for an existing product. Only you will try to update any new technology to the existing product, or you are going for a new product development. Okay. The ABC assumes that the design, whether product, a service, or a process, consumes activities. Okay. See whether you may go for product. Okay. If you go for product, so you should invest in the form of materials, right? You should invest in the form of materials. You should invest in the form of the machines, right, students? Right?
Yes, sir.
So a design process included, if you want to generate, or if you want to make a different design, then you want a product design engineer, you want a design thinking team. Okay, then only the design thinking team can give the inputs for the design thing, sorry, for the product design engineer. Then according to that, R&D department will be there. So there will be a lot of things will be there in the industry. So with respect to design, So there will be activity based cost. Okay, what the company will be investing, as well as once that design goes to the manufacturing department as a generating of the product, there also they should invest in the form of the materials. They should buy the materials. They should they want the machines. They want the employees. Okay, everything they should invest the cost. Then only they can produce the products, right? So this is called as ABC, that is activity based cost. Each individual activity so each individual activity, the CEO or the entrepreneur should invest the cost. Okay, ABC objectives is to identify activities in the design life and then assign variable cost drivers and consumptions intensities intensities to the activities. So see, this ABC is nothing but finding the cost. Okay, by using this activity based cost. Okay, as a entrepreneur, okay, you will identify the cost, how much I should invest in each process. Okay, in design phase, how much I should invest, in manufacturing the product, how much I should invest, for employees, how much I should invest, for everything. Okay, you can get the data. Okay, you can get the how much I should invest in each process. Okay, in each process, how much I should invest, how much I should invest the cost to produce the product. So this is called as ABC. So anyone has any doubt in this ABC? That is activity based cost. For each
No doubt, sir.
activity, okay, the CEO or the entrepreneur will be knowing he can know the cost, how much I should invest for each individual activity, okay, in the industry. Then design for cost. What is this design for cost?
So you need to make a product under a certain cost, so like you'll be making a certain amount of profit, sir. So based on the customer requirements, you need to select materials and all based on that, sir.
Yes, good. So this is called as design to cost. So how much I should invest? Okay, for producing one product or for manufacturing one product, how much I should invest. That is called as okay. That is design to cost. So if you are designing a product, so how much I should invest. So here you can see the design focus is shifted from what works to what works within budget. So what works is different. So with respect to the function, the customer needs, okay, we can manufacture the product. Okay, and you may invest more money. So right now, okay, you should know what is the budget. Okay, what I'm using to produce a product. So that's very, very important. So you can invest 1 crore or 2 crore rupees to manufacture a product, but you should analyze whether the customer can give back that amount or not. So you can invest 1 crore rupees to manufacture a single product, but you should know, but if I invest 1 crore rupees, whether the customer can give back that amount or not. So that's called as what works within budget. So you should put the amount, okay, that you should analyze whether the customers can give back that amount or not. Though depending upon that only, you should invest the amount. Okay, simply if you invest the amount, then the company will be under loss. So the company will see whether the customers can give back that amount or not. So whether that design, okay, will work within this budget. Okay, the company will fix the budget for each design or each product. For X product, okay, they'll fix the price. So this is the price, or this is the amount I'm fixing. So you should finish the product within this range itself, this budget itself. Okay, then only the product design will come into picture according to the fixed cost or whatever the budget, okay, the CEO fix or the entrepreneur fix. According to that only, okay, he will try to give the design, okay, of the product. I think everyone is getting right. Without this budget, okay, no company will directly, they will go for design part. So they will fix the budget. So within this budget only, we should finish the product. So anyone has any doubt in this, that this is called as design to cost. Okay, so regarding to the cost, they will fix the budget, then only they will go for manufacturing the product, or they will go for designing the product, then they will go for manufacturing. So anyone has any doubt in this?
No doubt, sir.
Then design for test. So what is this design for test, students?
So it should be able to meet all the parameters, like it should be able to withstand a certain amount of load, and the strength of the material and all those things comes under this, sir.
Okay, good. So whatever you told, it's in the first line. Testing may be an integral part of ensuring quality, right? If the material has good quality, that indicates it can sustain that much load, right? So if you use
Yes,
good quality material, according to the applications, regarding to that application, then you can tell the material can withstand that much load, and it can be or it may be demanded by the customers. Okay, if the customer feels that your product is very good, okay, very good with respect to all the accepts, then what happens? Okay, that the demand of your product will be very high. So that is what he is telling. So when you test the material, when you test your design, okay, it should sustain the load, okay, which is applying regarding to that application. I'm telling you, in different applications that the load will be different. So regarding to that only we should select the material, right? So in that cases, designs must accommodate an assemble test assembly type of production assembly process rather than rely entirely on functional test of the finished product. So what is the meaning? What is the meaning of this? Anyone?
Which one, sir? Can you repeat it, sir?
So the second line, in such cases, designs must accommodate an assembly test assembly type of production assembly process rather than rely entirely on functional test of the finished products.
So is it based on the assembly, sir? Like you need to design components based on the assembly, so you need to select the material based on it.
Okay. See, once you select once you done the design part, okay. Then, after that we'll select the materials. Once you select the materials, okay. After doing the assembly, we should do the analysis first. Then only we can go for the manufacturing the products. Without doing the FE analysis or FEM or whatever the different test you have, okay. Without doing those things directly, we cannot go for producing the products. So that is what he is telling. So after designing each individual part, assemble that. After assembling, do the analysis. Okay, after assembling, okay, then only you should go for means producing the parts, means producing the products. So that's what is to rely entirely on functional test. So functional test is nothing but initially whatever you should do FEM or whatever the initial test you should do, then only you should go for producing the products. So this is about design for test. To design for test, you should go for first you should test in FEM, FEA, okay. Then only we should go for producing the products. Then design for the robustness. What is robot? There is robustness, students.
Good quality products, sir.
Okay. Anyway, this I have mentioned. This I have told in the previous class also. This is regarding to the quality. Okay. Throughout the process, okay, you should get the quality products. Okay. So from first to the students. Okay, see, this indicates, okay, from first to the end, okay, you should give the quality products. So this is called as the robustness. The robustness indicates the output the products, okay, throughout the cycle from the first product to the 10,000 products. If the customer is asking 10,000 products, you should so there should be no variation, okay, in the output. Okay, so it should be the quality of the product should be same throughout the cycle. So this indicates the robustness. So anyone has any doubts? Example, you can go here you can see the size of the diameter. Okay, the size of the diameter, what they mentioned the customer. Okay, throughout the 10,000 products what we are manufacturing, the diameter should be same whatever the customer is asking. So that is an example. Okay, this is called as design for the robustness. The robustness indicates the quality of the product. The quality should be high. Okay, throughout the production of 10,000 products, your dimension should be same, as well as the quality of the product should be same. Then design for serviceability. What is this, students? What is this design for serviceability?
So like you need to design the product in such a way that even like after some time they use it, they need to provide the product for service. So you get like extra money from it, sir. And even it should be in such a way that the service shouldn't be charged more, so that even the customer is ready to get the service done from you.
Yes, good. So as a company, we should give this, that is service. If anything happens to the machines or the product, okay, the company person should go and he should see, okay, what has happened to the machines or product, and he should replace if the parts has been failed, okay, due to the wear or whatever it may be, okay, he should replace the parts, and okay, and he should repair the component or anything, whatever it may be happened in the machines, and you should satisfy the customers. Okay, if the customers are satisfied, then you can say then the company will get more profit. Okay, whatever the customer stored, okay, regarding to the service, okay, you should mention the less price. Then only the customers can get the service from our company. Okay, I mean that company. So this is about design for serviceability. So at the end, you can see there's a sketch, right? Can anyone tell what is this indicate sketch? Okay, another one I will explain you. So the last is end of life phase. What is this, the end of life phase? So there is a design for product retirement or recovery. What is this product retirement, students? What is this
Sir, like
product
is it you
retirement?
need to stop the production of a particular product, sir?
Okay, that indicates, okay, in the market your product has not selling well, so that is called as decline. So decline has come, decline stage has occurred to your product. Okay, recovery in the sense of, okay, so once your decline stage comes into picture, okay, in what way you can recover your product, whether you will update any technology to the existing product according to the customer needs, or you will entirely you will develop a new product so that the customers are satisfied. So retirement in the sense of, okay, your product as sales comes down, okay, at the end, that is called as the after the what you can say, the decline stage. Okay, after decline stage, whether you will update any new technology to the existing product, okay, you will do some strategy so that your product again sales moves up, okay, or you will go for a new product development. Recovery is nothing but updating any new technology to the existing product, and again you supply your product for the customers. Okay, if they're satisfied, again your sales moves up. Okay, again if the sales is not happening well, then you should go for new product development. So here you can see design directed at the planning of disposal. So retirement is nothing but disposal. Okay, that is you can go for recycle, right? So right students, you can go for recycling the products, right students, or you can go for use, or you can go for remanufacturing. I'll tell you all these things in the further slides. So can anyone tell now what is this? So this is called as design DFPR. Okay, this is DFPR. Wait students. So this is called as
It's given on
DFPR.
top, it's, sir, design for product retirement.
Yes, this is called at the end. At the end of this stage, the product will be the product will get retirement. That means the product is not selling well in the market, so that we should not manufacture that product again. If you want to manufacture the product, okay, we should put the strategy, we should use the strategy, and we should update the new technology to that product, and again we should supply for the customers. If they're happy, again it will go for selling well in the market. That is growth. Okay, growth of your product. Can you tell what is this slide or what is this diagram? I will
So
make.
I think basically it's the like starting of the product, sir. So first you manufacture it, then
Okay.
you assemble it, then you sell it, and you get the service done as you're using it. And once the life of the complete product is gone, you just like leave that product and go with a new product, sir.
Okay. See, this is the first indicates. Okay, this is conceptual design. I think everyone knows, right? This conceptual design and then embodiment design, then detailed design. So this I taught you in the product design process, right?
Yes, sir.
So product design process. So this indicates product design process. Your y-axis indicates the product design process, and x-axis indicates, okay, the component, the PLC, that is product life cycle management. Okay, your disease indicates, the y-axis indicates the design process or product design process, and x-axis indicates the product life cycle management. So here you can see component fabrication. So when you do the component fabrication, you should look into DFM, right? Design for manufacturing, right? So when you are
Yes, sir.
when you're manufacturing a part, if you take a if you're a car manufacturing, if you're working in my car manufacturing industry, for example, the component fabrication is nothing but fabrication of the each part, right? So at that particular point, you should look into DFM, that is design for manufacturing. Then see product assembling. So when you're assembling the car, then we should go for DFA, right? Design for assembly, right?
Yes, sir.
Right. So when see in design of assembly, okay, we should try to eliminate the number of parts. If you want to analyze, okay, initially only in design for manufacturing we can see, so what are the number of parts we have, okay, whether we can eliminate some parts, okay, while assembling, so that we can eliminate some parts, okay, initially in the component fabrication. Okay, then it will go for product assembly. Then we can assemble all these parts, all the parts, okay, of each part which we will assemble. Then we can go for DFX. What is DFX? DFX
So
indicates
design for
design for
excellence, the DFX.
design DF, so DFS. So DFS
Service, sir.
indicates
Design for service, sir.
serviceability. Then, so if anything happens to the machines, then we should give the design for to the serviceability, right, for the company, or for the company. Then it will go for product determinant at the end of this stage. Okay, if the product is not selling well, then what happens, that product will get determined. So this is about the design process. See, conceptual stage will convert into the embodiment design. Then after the detailed design. So once detailed design is over, then it will come for component fabrication, that is DFM. So here we will see whether we can eliminate some of the parts or not. Okay, this should be done in this should be done in embodiment design. So when we think the embodiment design, there itself we should try to eliminate some parts, okay, which are not used in the in the product, okay, or we can assemble two parts in a single part. Okay, we should try to analyze whether three parts can assemble and we can make a single product, okay, that's a single part. So those things we should think in the embodiment design. Then we should go for component fabrication. After component fabrication, we should come for product assembly, that is after manufacturing of parts. Okay, we should assemble all the parts, then use, okay, use the product. If you want some service, then we will provide the design for the serviceability. After that, at the end, okay, the product will get retirement. Okay, if you want to get recovery, then try to ask the customer needs. Regarding to the customer needs, that's functionality, then we can update your product, okay, update any new technology to the existing product, and we can supply the same product for the customers. If they're happy, if they're satisfied, then they'll use the same product. Otherwise, you should go for new product development, right? Again, you should go for conceptual design. So, right, students, right? Hello.
Yes, sir.
So okay, so this is about your DFX. Okay, DFX completes DFX includes the process. Okay, every process. Okay, it comes from design for manufacturing till the design for the means testing cost, then life cycle cost, means serviceability, maintainability, reliability. Okay, everything comes under DFX. Okay, if you analyze these things, okay, you should apply all these things once you go for manufacturing the products or parts. Okay, if you know what are the problems, okay, that are facing in the company, then use this DFX and try to eliminate the number of parts, or it may or you may try to do some analysis and try to improve the what you can say, the materials, this strength, okay, or which material I should use, or these are different types of methods or different types of tools what we can use, and we can try to improve the reliability. Then how we should maintain, okay, maintainability. Then how we can reduce the ABC, that is activity based cost, okay, for each individual domain or department. Okay, then then always we should focus on what works within budget. So we should fix the budget, and within that budget only we can go for the designing part, then test. Okay, then what about the quality of the products, then serviceability. Then after that, the last is retirement, product retirement and recovery. Okay, so whenever, if you want to do the recovery, what we should do. Okay, so all this comes under the DFX. I think everyone has understood DFX, right? So this completes DFX. So in DFX, okay, we will see all these things. Okay, design for manufacturability, design for assembly. Okay, then reliability, serviceability, safety, then product retirement stage. So then everything comes under the DFX. Okay, so DFX will use okay, to view the cost, how much we should invest for each department. So like material, or it may be design part or design thinking process. So we will analyze how much we should invest, how much how much we should how much is the budget to manufacture each product. So regarding to that, okay, we will see in each domain, so how much we should invest in design, how much we should invest, while purchasing materials, how much we should invest, for employees how much we should give. So everything we will decide initially itself. Then we'll go for the strategy for recovery at the end of life, recovery in product design. So what is this, can anyone tell me? So I think everyone has seen it. What is this? Strategies for recovery at the end of life, recycling in product design. So what we can
So
see in
it's
this
like basically your product is in decline state, sir. So
yes.
what you need to do, like you need to either update the product or come up with a new product. So for your product to be sold in the market.
Okay, good. So in the decline stage, this indicates strategies for recovery at the end of life. So this indicates whenever your product is in decline stage, okay, at the end. So what we can do? So what are the things we can do, and we can improve, or we can what are the different strategies? Okay, we can use, and we can supply the same product for the customers. Okay, so that is what we'll study in the strategy for recovery at the end of life. So what are the different strategy we can use at the decline stage? So whenever the product is in decline stage, so what are the different strategy we can use, and we can supply the same product for the same product means similar product for the customers. Okay, and the customer may be satisfied. So you can see in the there are five. I written the five. This one, right? The five steps. What is that repair at the end of your life? Product recovery stages. Sorry, strategies. First strategy is repair. What is the meaning of repair? What is the meaning of repair, students?
Repair, I think, if something happens to the product before its life cycle is supposed to get over. So you need to
Okay.
take it, repair it, and give it, or you can give you can give a completely new product and take the product and repair it and keep it for later sales.
Okay. Okay. Good. So you can see that flowchart, right? So what does the flowchart indicates? EOL. What's EOL?
End
EOL
of life
product
cycle,
collecting.
sir.
Okay, end of life product collecting. So if your product is in end, so if your product has been failed, okay, so we should collect the information, right? Why it has been failed, for what reason, right?
Yes, sir.
So that's called EOL product collecting. So EOL indicates end of life product collecting. So we should collect the information why the product has been failed. Example, okay, if you manufacture a car, and if you supply a car, and if you tell, okay, the reliability of my car is 10 years. Okay, example, okay, if it fails in a seventh or eighth year, if your engine fails, example, if you tell my engine will work for 10 years, if it fails 5 years or 6 years, okay, so what then you should change the engine, right? So you should collect the data, right, why the engine has been failed, right? So that is called as EOL product collecting, the collecting of information. End of life product collecting, that means collecting the information. What is the inspection? Can anyone tell me why we should do this inspection?
So inspection is done to find out why the product failed, sir.
Yes, that so
So
that
if you
indicates
find out the
inspection.
reason, you can rectify it and make a better product from it.
Good, Sachin. So inspection is nothing but, okay, why it has been failed. So actually it has failed in 5 years. Okay, example. Then if you do the inspection, so for what reason it has been failed, that okay, we can get the information in all those information. So only we should do the inspection. So if you do the inspection, okay, in the take the engine, okay, take the engine part, okay, do the inspection. How you should do the inspection? We should we should do to disassembly, right? So we should all the parts which is connected in the engine, we, we should disassemble it, right?
Yes, sir.
So once you do the disassembly, then only we can see the engine part, the cylinder, we can see the piston, we can see the connecting rod, we can see the shaft, everything. So once we disassemble all the parts, and we can see, okay, actually what has happened inside the engine, right? right? So when once you do the inspection here, so you got the information that okay, the owner has not given the service, okay, means regularly. It means okay, the yeah, means the owner will tell, or the CEO will tell, or the entrepreneur will tell, okay, change the engine oil regularly, three months, okay, regularly. If the owner has not done that, so so what what may the entrepreneur can tell to the owner of the car? So what may be the answer he may give for
The
the
answer might be like it was due to their own mistake that they didn't
hmm,
notice and they didn't change the oil on regular basis. So
hmm,
what they can do is they can charge them for service, repair it, and give it to them. Or if it
okay.
is like if he was following the entire thing and it happened due to the design problem, then they're supposed to give a completely new product to them or do the service for free.
Okay. So as usual, whatever the Sachin told you, you can see the right part. Okay. See recycling, disposal. So recycling in the sense if the product is good. Okay. If the product is good, okay, then they will do then they can use that engine to the other to the other car, right? Recycle means they can use they can use that product as a second what you can say so they can remodify means everything, okay, they can remodify that engine part. Okay, if you see example, if cylinder is gone, okay, example cylinder has won the wear rate is very very high, so that the boring is happened, so they can replace only the cylinder, right? They can throw the cylinder, or they can dispose the cylinder, and they can replace the new cylinder, right? And other parts like engine, sorry, other part like your piston, connecting rod, and crankshaft, everything we can use same, right?
Yes, sir.
So that is called as recycling. So recycling is nothing but okay, what are the parts so what are the parts, okay, it is good, it is good it is in good condition, so that good conditions parts we can use. And whatever the part, okay, which is gone, like your cylinder, okay, cylinder, if there is more wear, so that part only we can replace, right? You see, if all the parts are gone, then we should go for part remanufacturing, right? So you can
Yes,
see
sir.
at the end, see part remanufacturing indicates if all the parts are gone. Like in engine, if you say conducting rod, crankshaft, cylinder, piston, if everything is gone, okay, if everything is not working, not working, not in good means working condition, then we should go for part remanufacturing, right? In this, you can see here new parts. Then we should manufacture new parts and assemble the new parts, everything. Then we should replace a new engine in that car, right? So this is called as old product remanufacturing. I think everyone has understood, right? See, only one thing.
Understood, sir.
See, only one part is failed. Only one part is not working correctly, like the cylinder. Then that single part is replaced. Okay, that cylinder will be disposal. So that cylinder will be that is disposed. Once, if all the parts are not working in good condition, then we will go for part remanufacturing. In that, we'll go for manufacturing of new parts. Okay, all parts will manufacture new. Then we will assemble. Whole product will be reassembled, like your engine. All the parts will be reassembled, and we will put in the car. So this is an example what I'm telling you. So it will start from EOL, that is end of life product collecting of engine. First we will inspect. First we will do the inspection. So for what reason the engine has failed? Okay, then we will go for disassembling. Means we will disassemble all the parts. Then we will check which part has been failed, like cylinder. So then we will dispose that cylinder. We will take the other cylinder and we will place a new cylinder there, and we will give the engine to the car owner. If all the parts are gone, then we will go for part remanufacturing. We'll go for part manufacturing, and we'll go for new parts. Okay, we'll manufacture new parts, all the new parts like engine, a cylinder, then piston, connecting rod, crankshaft, everything we will manufacture new. and we will assemble a new product in the car, and we will supply for the owner. So this is what it will flow in the industry. I think everyone has understood, right?
Yes, sir.
So here you can see there are five. I've written the five strategies. One is repair. Okay, if anything happen, okay, inside the engine, okay, then we will try to repair. Then what is this? Means what is this? That is to refurbishing.
Refurbishing, sir.
What is this? Refurbishing.
Sir, like example you can give is like you buy an old apartment, you just
Okay.
like repolish them and make it a new kind of apartment and sell it.
Okay. So this is nothing but like a invention. That is, we will try to invent, means we will try to re-innovate,
So
right?
it's kind of converting a old product into
Old one.
something a useful product, sir.
Yes. That's called re-innovate. So this to refurbishing is nothing but re-innovate. So we will try to re-innovate a new one. So old one we will try to re-innovate like a new one. So that is called refurbishing. Next, remanufacturing. What is this remanufacturing?
So that's based on again on parts. So you said no, if some parts are damaged, so you like completely remanufacture those parts,
Yes.
or like only just replace few parts with the newer parts.
Yes. Next is reuse of component. If
So
the
if the
components are
components
good,
only like if only one or two components have damage and rest other components are like working they are required, so you can
yes.
just reuse them.
Yes. Now last is material recycling and disposal. So if the parts are okay, then we can recycle that. So those parts which are not working in good conditions, then that parts will be disposal. Then that will try to, okay, we will try to dispose those parts. So these are the five techniques or five strategies, okay, that the company will be using. Okay, so this is called as the strategy for recovery at the end of life. So tomorrow I will teach you this these two slides. Then we'll go for the last this one. If anyone has any doubts about the design for X, you can ask me.
No doubt, sir.
Okay, I'll take attendance. Don't give the class. 2 minutes. Okay. Okay, students. If you have doubts, you can ask me. Otherwise, you can leave the class. Thank you. Thank you, students.
Thank you, sir.
Thank you. Bye, students. Bye. Recording company.